More work. So, everybody should better look at that. Would anybody like to tell me what they have for an answer? Ashley. 4 hours. Ashley, please tell me how you found that answer. How did you know to go right to 4?
No, never mind. You go to 320.
There you go.
You go right and then you see when you go.
Excellent. So Ashley says that you go up to 320, which is the distance you care about, yes? And then you go out until you find a line. So that has the y value of 320, doesn't it?
And it makes a triangle.
But it's got no x value. The x value is where the time is. So I go down, and I find the time was 4 hours. So the point on the graph is 420, or 320, and the x value is the time. So it took her 4 hours. Does everybody see how that works?
Yeah.
Great. Now tell me, how far did they travel in 2.5 hours? Now what are you going to have to do? James?
You go up to 240 and
No. 2.5 hours.
2 and 30.
You go out the middle.
You go out to the middle between 2 and 3 and go up to the line and then out to here. And what would you say is your answer?
2.5. Oh, you have to figure it out.
Yeah, sure. Around 200 kilometers. Is everybody cool with what we did?
Yeah.
If you get a value that is on the x-axis, you slide out to that value, then you go up to the line, or down to the line. If you get a value that's on the y-axis, you slide out the y, and then you go out to the line to get the x value. Pretty easy, yeah?
Yeah.
Okay. So, this is what we call interpolation. And it is called interpolation because when we use the existing, please underline or highlight the word existing. When we use the existing data from a graph, we are interpolating. Nice spelling, Myers. So what do I mean by that? That means the x and y we want are on the graph. So, knowing what you know now about that word, interpolation, and what it means, tell me what the only times that you would be allowed to use to interpolate on this graph. Times are in hours. So what is the only times you could use to interpolate for this graph? No. You just did interpolation with 2.5. So obviously 2.5 is okay. All of them? Every time. Every time in the universe is on this graph. No. So try again.
5 or 6?
Up to 6. So I can interpolate any time from 0 to 6 hours. Yes? What is the distances I can interpolate?
0
420?
No, 480.
0 to 480 kilometers can be interpolated. Why?
That's enough.
Because that's what's on the graph. Everybody cool?
Yeah.
Okay. Do it now. You got 2 blanks to fill in. Fill them both in. I'm going to do the first one in a red line and the second one with a blue line. Excuse me. So for the first one, will I be starting on the x or the y axis? Absolutely. Why do I start on the x axis, Omar? Because liters are on the x-axis, and I have a liter. That's the only piece of information I have. So how far along this line do I slide? I got to go up to 15. Well, that must be right there, correct? Halfway between 10 and 20. Do I have a cost yet? No, I must find the cost by going up to there, and then what? Draw the line over here to get an answer. So approximately how much is 15 liters of fuel? It's about $13, which tells you how old these notes are.
Oh, yeah.
How much does it cost now?
It'd be about 16 bucks.
16 or 16?
16.
You say 60?
16.
Oh, okay.
Gas is $1.05 a liter.
16, and then I thought you said 60 was 70.
Everybody good? Okay. And we interpolated because the x and the y that we wanted were indeed, oops, I didn't want to do that blue, were indeed on the graph, weren't they? Right? Now, just to remind you of yesterday, this point right here, which you say is 15, 13, correct? That's an x and a y, yes? So if we had an equation, what would we know about the 15 and the 13? The equation would be something like cost equals 0.9 liters plus maybe 0.05. What would go in there? Where would the 13 go? For the C or the L? The C, because it's the output, and the 15 you could put in for the L. And this would be equal, wouldn't it? Because that dot's on the line, right? Okay. Now, for the blue dot, blue question, B, where do I go? I go up to 10 on the y-axis, because that's the information that I have. Then I slide across, and then where?
Go down.
Slide down, and what do I find?
That's like very close.
It's a little bit more than 10. I would be perfectly happy if you said 11 liters. Is everybody good?
Is it okay for your like 1 point off?
Of course it is, because you're using a graph. You don't know it exactly. If you had the equation, could you give me the exact answer? Of course you could.
So like on a test, if you're like 1.
It would be depending on what the point of the question was. If I'm testing your ability to interpolate, then I don't care as long as you're close. If I'm testing your ability to substitute into an equation and tell me an actual answer, then it needs to be exact. Everybody good? All right. So you guys are smart kids. Let's have a look at this. On his family trip from Calgary to Moose Jaw, Bobby wants to predict how long we'll take to travel 640. What's wrong with that?
It's not on the graph.
It's not on the graph. Is it?
No, but you can keep going because you know the amount.
Why are we allowed to keep going, James? Why are we allowed to assume that that is going to carry on?
Because you see the graph.
Because it's a linear relation, isn't it, Tasha? For 80 kilometers, I go 1 hour, yes?
Yep,
And does that carry on?
yep.
Now, so all we got to do is say, all right, well, if it's 80 kilometers in 1 hour, I want to know how long it's going to take to go 640 kilometers, yes?
Yes.
So this fraction is going to have to be the same, isn't it? Well, what do I have? Do I have a kilometer or do I have a time? A kilometer. What is the kilometer I have? 640. We already had 80, but we want to know about 640, don't we? What do we not know? The time. You guys know how to solve that. What do you do every time you've got two fractions?
Cross multiply and divide.
Yes. Cross multiply and divide. So, which pair multiplies? The 1 and the 640 or the 80 and the 20? The 80 and the T. The 1 and the 640. So when you are faced with this, we do 640 times 1 divided by 80 with our calculator. And what do we get? 8 hours. You also could do it this way. These are two fractions, aren't they? What did you multiply 80 by to get 640? Well, 8 times 8 is 64. So if this was times 8, what did this have to be? Times 8, or the fraction would be different, wouldn't it? Is everybody good with that? Now, here's where it gets tricky. Is extrapolation, which is what we just did, this is extrapolation, is it as reliable as interpolation?
No,
Why?
because it's a translation.
Right. What could happen after 6 hours of driving?
You would have like
I could take a nap. Mom could take over driving and the speed could change. Right?
get into a car crash.
Right? All kinds of things can happen off that graph. So extrapolation is what? It's a prediction, isn't it? Really, it's just a guess, because we don't know, because we don't have data for it.
So it's an estimation based on the chance.
Yeah. Is everybody okay with that? So, what's our definition for it? If
It's a linear
we extend our data and assume a linear relation, because that assumption might not be true, and we assume a linear relation, then we are extrapolating. Yeah. We are extrapolating. So what is the assumption that we make? That the rules for our graph will what?
Could change.
No. We're assuming that they won't change, right? We're assuming that the rules for our graph will continue. Because we are using it to predict a value that we do not have. Does everyone understand? Interpolation, in the graph. Extrapolation, I need extra data. Everybody cool? All right. It's pretty easy. It's just fancy new word. So, look at this next graph. Is it inter or extrapolation?
Wait, no, it's actually
And you could extend.
It's an extra.
It's extrapolation, isn't it?
Because they can continue.
Because the graph ends at what?
But can't you?
No,
Just
because we can't.
the graph, the data we have, Ashley, ends at 20.
It can just flop.
You have no idea what happens after 20, right?
It could come against, like,
Okay? So how are we going to do this? 30 liters. Where do I go? The x or the y-axis? Why the x-axis? Because I have a liter. So I go out to 30 and I do what? Go up. Oh, no! There's nothing there. So this, I can assume that this is a linear relationship. I don't know that it is, but I can assume that. So that would mean this line would do what? Continue. For how long? To infinity and beyond. So here is where it crosses, yes? So now what do I need to do? I need to go over to the x-axis, or the y-axis, and what would you say is about the answer?
26.
Sure, $26. Is everyone okay with this? Now, believe it or not, it's that easy. You either read the graph or you extend the graph. That's it. There's no tricks. Absolutely none. But people screw it up all the time. Especially when we stop using real life examples and go to x's and y's. So, let's practice. Use this graph, this one right here. What is the value of x when y equals 3? So where do I have to go for a?
To y.
Up to 3 on the y. And then I look for a line. Uh-oh, doesn't hit. So is this inter or extrapolation? This is extrapolation. I'm so lazy, I'm only going to write extra. So the line's got to continue. Now, you guys can see it goes up 1 over 1, up 1 over 1, yes?
Yep.
So it's going to hit right there, isn't it?
Yep.
So what value is that?
5.
5. Easy peasy lemon squeezy, yeah? Okay. Now, what is the value when x equals 1? So where do I go?
The 1.
I go out to 1 on the x-axis. And then I do what? I go down, oh, and I hit line. So is that inter or extra? That's inter, because it's on the graph, Omar. And what's the value?
-1.
-1. Everybody good? Okay. Now,
Screen flashing through this one.
guys, For these two questions, is extrapolation as exact as interpolation? For these two questions. Yes or no? James says yes. Why?
Because it's still on the line somewhere, because it's on a continuation of things. And it's exact numbers, not the halves or points. It does not.
Not quite. What are these graphs of? They're not data, it's just numbers, yeah?
Yeah.
So read this sentence to me.
Oh, it's a linear relation.
It is! This is a linear relation, isn't it? We aren't assuming that it is. It is. So we know that that line is going to do what? Continue. Because it's just numbers. It's not a real life thing, yeah? Okay. So, let's do the next one. When y is 4, inter or extra? Extra. Because y is 4 is not on the graph. But, oh, no, y is 4. So I go up, up, oh, and there it hits. What's the value? 3. When x is negative 4, inter or extra? Extra, because x doesn't actually get to negative 4, does it? And I gotta go down and I hit nothing. So I can continue the line. There it is. And what do I get? Negative 3. Can everybody do it?
Yes.
Good. Do the last question by yourself. Yes.
Oh, wait, it's this one? Wait, can I use the washing?
No. Did I forget to turn my water on because the phone rang? I think I did. Zach, reach over, flick that green switch up. Well done. Way to go, buddy.
You're learning how to make tea.
Somebody want to give me their answer number 1? Okay. And is that inter or extrapolation? Inter. Well done. Who would like to give me their answer to number 2?
1,000.
Sorry, Omar, number 2? It's going to take 1,000 days. What is it, Ashley? 1.5. Inter or extra? Inter, because it's on the graph. So let's talk about those two. For 1 day, I go out to 1 day, I go up, and I go over. For the next one, I go up to 750, and I go out and then down. Cool? Oh. Yeah. Well, 500, 1,000 halfway between is 750, 250 away, right? All right, let's do the next one. 3 days. Is that on the graph? No, so that's extra. How are you going to do it? out to 3, up. Uh-oh. It's not pretty, is it? But I do know I go up 2 and over 1, up 2 over 1. So I go up 2 over 1, which will be 1,500, because we've gone over to here to check. And then 2,000, up 2 over 1, right there. 2,000 over, down. 4 days. Can everybody do it? It's so not difficult, is it? You just look on whichever axis that you have the information for and go to the line. And then go back to the other axis. Easy. Right? Okay.
That's it.